Okay, this one's a little bit different when we're finding our zeros, because notice our power is a 4, right? So there's a little thing that we have to do to help us get down to a squared, because we need to get down to a squared so we can factor it or use the quadratic formula. So again, we're going to start with our P over Q list. So our P is the constant and our Q is the leading coefficient, or our rational root theorem. It's another word for it. So we're going to do plus or minus 1 and 60, and then 2 and 30, and then 3 and 20, and then 4 and 15, and then 5 and 12, and then 6, and I ran out of space, 10. There's a comma there. And then 7 doesn't work, 8 doesn't work, 9 doesn't work, and then we're to 10, right? So then we've got all of them all over, and then our leading coefficient is 2, so plus or minus 1 and 2. So we're going to take each one of these numbers and divide by 1, right? So then it ends up looking pretty messy when we go like this. So I've got plus or minus 1, 2, 3, 4, 5, 6. I'm going to put 10 right here now. 10, 12, 15, 20, 30, 60, right? But then we need to do 1 divided by 2, 2 divided by 2. So 1 divided by 2 we don't have yet. Why was color on red? Yeah, whatever. So 1 divided by 2 is a half. 2 divided by 2 is 1, which we have. 3 divided by 2 we don't have. 4 divided by 2 is 2, which we have. 5 divided by 2 we don't have. 6 divided by 2 we have, which is 3. 12 divided by 2 we have, because it's 6. 15 divided by 2 we don't have. 20 divided by 2 is 10, which we have. 30 divided by 2 is 15, which we have. 60 divided by 2 is 30, which we have. And then the 60, I think I just said this one, 60 divided by 2 gives us the 30, and then the 10 divided by 2, which is 5, which is something we already have. Right, so then these are all of my numbers possible. Right, so this is a larger P over Q list, right, which means that we should be super grateful that we can just flip over to a graphing calculator and pick one that works for us, right, instead of just trying all of those to see what works. Okay, so I can see here that it crosses at 4. So I'm going to go back and look, and 4 is on my list, so I'm going to synthetically divide by 4. We have 4, 3, 2, 1, none. So I'm just using all of the coefficients. So 2, negative 5, negative 22, 25, 60. So I bring down the 2, gives us 8. This gives us 3. This gives us 12. This gives us negative 10. This gives us negative 40. So if we do 25 minus 40, that gives us negative 15. And then we times by 4, which gives us negative 60, which is 0. Ta-da! But if we go 1 power lower, this is only a cubed, which is not as helpful for us. So you can synthetically divide again. So I'm going to go back and look at my picture. So here, if we look, it's a little past 2, and it doesn't look like, if I go look at my fractional numbers, we've got 1 half, 3 halves, 5 halves, and 15 halves, so it would have to be directly in between 2 whole numbers, so that's not going to work. And then I've got this number that's not halfway in between. So if we look at this one, the one between negative 1 and negative 2, it's directly in between. So I'm going to go look. Negative 1 half is the same thing as negative 3 halves. So we're going to look at the 3 halves. So I'm going to synthetically divide by 3 halves. But what I'm not going to do, notice if I were to start again and do the negative 3 halves with this, it would just knock it down to a cubed again. But I know that I can, that the negative 3 halves is a factor. It's also a factor of this one, right? Because we only divided by our first factor. So that means it's a factor of the second one, so I can synthetically divide by this one. So what we do is we just do like this extra add-on for our synthetic division. So I bring down the 2, and then we're going to do 3 halves times by 2. Sorry, negative 3 halves times by 2. Remember, when we're multiplying fractions, multiply straight across. We can cancel the 2's here. So that gives us negative 3. I add straight down. That gives us 0, which is great. That gives us negative 10 when we add. Then I'm going to do negative 10 times negative 3 halves. So 10 is over 1. The 2 and the 5, or sorry, the 2 and the 10 can reduce. 2 goes into 10 5 times with a negative. 2 goes into 2 once. So I get positive 15 over 1, which is just 15. And then I add straight down, which is 0. The 0, 0. So when you do it the second round and you want it to be a factor, you need double sets of zeros. Right? So this was representing the 0 for the first one. This is representing the factor for the first one. This is representing your factor for the second one. So if you're synthetically dividing a second time, you need 2 sets of zeros. Right? Well, this was a cubed. So we synthetically divide it, so it knocks it down by 1 more power. So from a cube down 1 more power takes us to an x squared. So now we have 2x squared plus no x minus 10 equals 0, right? And we want it to equal to 0 because we're still finding the zeros, or the x-intercepts. Finding the x-intercepts, you set the y equal to 0 and you solve. Okay? Well, since this doesn't have our middle x term, I can just solve using what we call the square root property. So I get 2x squared equals 10. So I divide by 2. So then we get, come up here, x squared equals 5. So when we take the square root, remember we have to take plus or minus the square root. So x equals plus or minus root 5. So if I wanted to write this in factored form, I would have x plus root 5, x minus root 5. Oh, I forgot the root. I'm struggling. There we go. But don't forget these two things, right? So x minus 4, and you could either write this as 2x plus 3, or you could also write this as x plus 3 halves. Both will give you the same thing. So that would be how our polynomial would be written in factored form. If you're just listing the x-intercepts, your x would be plus or minus root 5. I can just keep those together. Don't forget the 4 and the negative 3 halves. Now, when we're looking this way, you're either looking at the power that it came from or how many times it shows up. So each one of these showed up on their own, which means that they're all going to have a multiplicity of 1, so they're all odd and crossing. And I'm remembering that the plus or minus is really 2 of them. I just write it since they're the same with opposite signs like that. Okay, so, and I have 1, 2, 3, 4. It's crossing. 1.5, negative 1.5 is crossing. And then if we find root 5, we get 2.23. So really just 2.2 is really what we care about. We're not going to be any more precise than that in our graphing by hand. So 2.23 and then 2.23, so like there, cross, cross. And then remember, our power is an x to the 4th. Our degree is a 4. It's even, so it's going to be touchdowning. Since it's a positive 2, it's going to be opening up, up. So our end behavior looks like this. Right? If we find our y-intercept, that means I'm plugging in 0 for all of these x's, which all go to 0, and then we just get 60. Or remember that your y-intercept is your constant. Right? So 2, 4, 6, 20, 40, 60. So I can scale it that way. So I'm going to come from the top left, and I'm going to cross, and then I need to come up here. Now maybe I come up here and then hit it on the way back down. We're not being that precise. There is only one way that it does happen, but we're not caring about that part right now. And then we're crossing and then crossing, so we get this kind of W shape.